Good afternoon, good evening, hello, welcome to another math lesson with Mr. Refer. Today we're going to be continuing our Unit 5 lessons, looking at lesson 5.5b. I'm hoping you guys are all excited and ready as we go into this. As usual, if you have the packet with you, please look on with us as we look at 5.5b. It talks about graphing proportional relationships. As a recap, remember if you look at a table or an equation or even a set of points, it will be proportional if there is a constant that exists. How do we find the constant? Constant is represented by the letter K. K can be found if you do y divided by x. If you end up getting the same constant every time you do y divided by x, then yes, that is proof enough to know that that particular relationship is proportional, which means there's a constant movement to go from one number to the next. No matter what pair of numbers you're given, you could find a missing number or a part of a whole because you know that there is a proportionality to it. All right. Let's look at the bell work as usual. Take this time, pause the video to work on the bell work. I'll give you a few minutes and then I will jump in and fill in the information. It's asking you to create a table and then graph the points of that table from this statement that's written. Awesome. As we look at it, I'm hoping that you also notice here that they're telling you 30 bicycles are produced every 2 hours. So they might want to find out the unit rate or the other than unit rate, they might want to find the constant of proportionality. We could do bikes over hours to figure that out, right? So bikes per hour. And the reason why I'm writing it like this, because I want you to understand something. When it's written as bikes per hour or as it's written here, that is indicating to you that bikes is on the top being divided by the amount of hours. Now, you and I both know to find K, it's normally Y divided by X. So I want you guys to understand something. In this case, bikes are going to represent your Y, hours are going to represent your X. Let me explain that once again so you can understand how this correlates to what we're doing even today. When you see bikes per hour or something per something else, you can write that as a fraction, bikes over hours. And because you and I both know we're calculating K or finding the constant or finding the unit rate, it really means Y divided by X. So that tells you that the top unit, in this case, bikes, is going to represent my Y's, and the bottom unit, hours, in this case, represents my X. Even more so, to try to help you guys see that, if you look at this particular graph, you'll notice that the x-axis down here is labeled hours as the y-axis is labeled with bicycles. Just to pull that together so you can see how it works. Now, to do the math here, I'm hoping you all did 30 divided by 2, and you was able to get 15. Now, 15 really means 15 bikes per hour. You could draw a table as it's asking you to draw a table. We have worked with tables already. Right? I draw myself a table. Let's say the top here is going to represent hours, right? Because we know that that needs to be X. The bottom is going to represent bikes. Okay? And once again, I'm going to put just X and Y out there so you can see that that's X, this is Y. All right? And then we'll just fill in some data points in this table. So at 1 hour, we know that's 15 bikes because we did 30 bikes divided by 2 hours. We know it's 15 bikes per hour. That's what this means, 15 bikes per hour. So at 2 hours, we know that's 30. That's what it told us. 3, 45, 4, 60, 5, 75. Okay, this is our movement that's happening here. But we're not done just there, because the good thing is that we're able to take what the points are on the actual table and then graph them. Now, you should know that all of these are coordinates. So for example, we have coordinate, we have coordinate 1, 15. Okay. We have coordinate 2, 30. We have coordinate 3, 45, etc. Right? These are the pairs that I'm getting when I look at the table. I can go and graph that. Now, how you decide to graph it, it depends on you, but you do need to graph this data. I noticed that this corner here, which is the origin. So whenever you look at this graph, remember, put a 0 here, because that's 0. It means 0 hours, no bikes are done. So when we think about that, think about this. Why does it have to start at 0, 0? because it's proportional. If no hours are passed, then no bikes are made, right? And that's the correlation between proportional relationships. The question and the essential question is, why does it have to start at 0, 0? If nothing is happening, there is no result. They are dependent on one another. Let's say that, right? Even though X is the independent variable, time can go on without Y, but Y depends on X. So since we're trying to figure out where Y is when X is moving, we know Y is not going anywhere. So because of that, it stays at 0, 0, and that's why we have to start at 0, 0. You could label this 1, 2. Notice that I'm skipping every other line here. You could do this. You could do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Whatever you feel more comfortable doing. Even here, you could do 15 all the way up. I'm going to skip every few. Make that 15, right? Make this 30. No, you're not going to. Make that 45. Make that 60. Make that 75, okay? So notice that I did that. So I know the first point, when I go to graph this, the first point needs to be at 0, 0. Then at 1 is 15. 2 is 30. 3 is 45. 4 is 60. 5 is that, and 6 would be up here somewhere. Notice, ladies and gentlemen, what this looks like. This is a major point that I want to make sure you guys notice here. When we graph proportional relationships, notice that it makes a nice straight line going through the origin, okay? Right, I can pick any one of these points and pull out data from it, but this is what you should have done for your bell work. Should have made a table, recognized the unit rate was 15, recognize that at 1 hour, 15 bikes are made, and worked your way up on a table that you would create yourself, understanding X is hours, Y is bikes. You could have got that from the table, or you should have got that from bikes per hour, all right? Now, this is very similar to what we're going to do today. So I'm going to go through it. Hopefully, you'll gain a better understanding of exactly what to do. As usual, if there are any questions, feel free to put them in Google Classroom where I'll be able to get back to you quickly, all right? All right, students, once again, if you have any questions at all, make sure you put your questions in Google Classroom where I will try my best to respond as quick as possible, all right? Look at the modeling with me. Now, what we're doing today is we're doing a number of things. We're going to take a statement, a sentence, or a particular scenario. We're going to take that scenario, identify the equation from it, and from that equation, we're going to make a graph, make an actual graph done. Notice in the bell work, we could have wrote the equation for the first one here. All right, my question to you could have been, if we do this in class, well, what's the equation? You could tell me Y is equal to 15X. This means after every hour, because X represents hours, 15 bikes are made. That's what this means. So I would say, okay, 1 hour, 15, 2 hours, 30, 3 hours, 45. Did I need to make this whole table and everything? Not really. I could look at the equation and say, okay, go up 15, go over 1. Go up 15, go over 1. Up 15 over 1. Because that's what I'm doing here. I know 15 as a fraction is really 15 over 1. So go up 15 over 1, 15 over 1, 15 over 1. And I want to show you a little bit of that as we work on graphs today. First, we want to talk about Megan. And we got to understand what her equation is. Megan earns $12 an hour. You should know, since it says $12 an hour, hour being singular, this is your unit rate. Okay, this is your unit rate or your constant. Okay, it's your unit rate or your constant, which is equal to 12. Okay, so my equation has to be Y is equal to 12X. Okay, now what does this mean? This means that Megan makes $12 every single hour. $12 every single hour, right? If you need to, you understand that it's earned per hour, or yeah, I can write earned per hour. Okay, that's what we're talking about here. Oh, I apologize. I must have went to the next page. Let me go back. Earned per hour. And that is as simple as saying money over hours. Okay. You and I both know, once again, it's always Y divided by X, which means that Y in this case is earned money, whereas X in this case is hours. So when I go to my graph over here, I got to label. This is a big deal, ladies and gentlemen. Make sure you're labeling your graphs, okay? You got to label it. I got to write hours down here. And I can write a little X here to represent that that's X, hours, right? You can write hours worked, anything like that. On the Y-axis here, I need to indicate this is money. You can put a money symbol, or you can even write the word earned. Okay. Yes, I'm writing this sideways because that's normally how you see tables as they're written, right? And that's EARNED. I know that looks like an M, but it's not an M. It's an R and an N. Okay. Every proportional graph starts at 0, 0, right? We want to label this 0 here. And we want to then label our graph to know what the numbers are. We're talking about hours. So we just go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, if you like, right? But notice that is $12 per hour. So I'm gonna go like 1 hour there, 2 hours there, 3 hours there, 4, 5, 6. Now throughout this worksheet, there is nothing wrong with you skipping. If you want to skip, that's fine, right? It works out perfectly fine. Mine, I'm gonna skip up. I'm gonna do this by, let me go by 6. I'll go by 6. 6, 12, 18, 24, 30, 42, 48, 54, 60, right? 66. Sorry, it's glitching a little bit here. Right, so 66. 54, so 60, 66, and then finally 72. Yeah. Either way, you make your list and then you go and graph your points. Now, my points here, I noticed at 1, right? If you want to make a table, ladies and gentlemen, the table's fine. I'm not sure why it's doing all this weird stuff, so I apologize, ladies and gentlemen. Hold on. Let me just fix this. I'm not sure why it's doing all this. Give me a second. Let me just fix this. I'll fix it. There it is. Okay, so I just want to fix that just to make sure it's lined up. I'm sorry about the technical glitches. I guess my pen or something is a little faulty today, but nonetheless, let's talk. If you want to make a table to represent this data, that's okay. That's why we did that in the bell work. So in case you want to make a table going after 1 hour is $12, 2 hours, $24. So you can see it, that's okay. That works. On the other hand, I'm going to do something different. I'm going to say, okay, it tells me to go, it's really 12 over 1, which means it goes up 12 right here over 1, and that's going to represent my 1. Go up 12 again, go over 1. Now I know it looks like I skipped over 2 here, but that's only because of how I wrote out the x-axis, okay? Up 12 over 1, and you'll notice I'm going to continue this pattern because this is how proportional relationships work. There's a pattern, there's a constant, there's something that is always going to be the same. And you see that, you get something like this. Now notice at the end of all my lines, I always draw this arrow. Now, why do I draw this arrow? Because it just means that the graph just keeps on going. Now, this is what you're going to end up doing today, ladies and gentlemen. You're going to read a statement or a scenario or story. You're going to identify the constant, the unit rate, write the equation, and then graph that equation. If you need to make a table, understanding what you're doing in intervals, that's perfectly fine. Okay, feel free to do that. Once you do that, please go and graph it. Take your time, label everything, show out the numbers, and you see all the work here to fully understand that you understand how to graph this. All right. If there's any questions, once again, feel free to either rewatch the video, put a question on Google Classroom, or ask a classmate who may understand it a little bit better than you. All right. So that is it for today. Thank you so much for joining me once again with another math lesson with Mr. Winford. You guys are intelligent. You guys are awesome. Have a wonderful day.